Today we're going to discuss some characteristics of functions. In Algebra 1 we knew them as x-intercepts. What we're going to start referring to x-intercepts as are roots and zeros, just another name for something we already know, and we know that an x-intercept we can find by setting y equal to 0. And that's going to happen for every function we ever talk about. So if we want to find the roots or the zeros of these two functions, we set the y equal to 0. We know f of x is equal to y. So in this case, we have 0 is equal to square root of x squared plus 7x plus 6. Square both sides, continues to give us 0. That's x squared plus 7x plus 6. And we can go ahead and factor that into x plus 6 and x plus 1. So we can then say that x is going to equal negative 6 and negative 1, and those are our x-intercepts for the graph, and we don't even know how to graph that function yet. Likewise, we have a rational function over here that at this point we don't know how to graph, but we can still find its x-intercepts by setting the y value equal to 0. So if I do that, we've got to solve then for x. Easiest way to do this is to multiply both sides by my denominator. So if I multiply the quantity of x plus 3 and x minus 2 to both sides, notice this will go to 0. So that leaves me with 0 equals the quantity of x plus 8 times x minus 7, thus giving me negative 8 and 7 for my two intercepts. Next, we're going to talk about some increasing and decreasing intervals of functions as well as maximum and minimum values. Let's say this is our function, and in this function, let's say this goes on forever. Just like we read a book, we read functions kind of the same way from left to right. So if I read this function from left to right, I see that as I follow it this way, I notice my pencil's going down. So at this point, it decreases over this amount of time. And then it goes back up, increases here. Once again, goes down, decreases here, and finally finishes by increasing here. Now, if we want to talk intervals of increasing and decreasing, intervals refer to x values. So when we talk about when is the function increasing and decreasing, we talk about over what x values does it increase and decrease. So let's just guesstimate. Let's say this point right here is roughly negative 1.2 and 3.3 negative. And then we'll say this point right here is 0.1 and 2.1. And we'll say that this point is 1.5 and 0.3. And that would be negative. So given that, if I wanted to state where this decreases, we usually do it in interval notation. We say this goes down when x is very negative until x gets to negative 1.2. So we go from negative infinity to negative 1.2. This is going to decrease. It's also decreasing when x is 0.1 to 1.5. As far as increasing, we say this function would increase from negative 1.2 to positive 0.1 and then from 1.5 to infinity. In terms of maximum and minimum values, we talk about the highs and lows of the graph. Now this graph continues in the upward direction forever when x is very small and x is very big, but we notice that we have some plateaus, one being a high point right here, a low point here, and a low point here. When we talk about high points and low points, that's when we talk about maximum and minimum values. So in this case, this is a maximum value right here, but since it's not the highest maximum of it all, we call it a relative max. Likewise, this is a low point, but since it's not the lowest point, we call this a relative min. And this point here is also a low point, but it happens to be the lowest point of all, so we call this a global min. Now, we've labeled these, but in order to state what is the maximum and what is the minimum values, when we talk about these, we're talking about y values. All right, that is the max or the min value. We speak of their y values. Where they happen, those happen to be your x values. So if I wanted to state some of this, I would say I have a relative max of, so I look over here and I say, well, this is about 2.1, that's its y value, at an x value of 0.1. Likewise, I have a relative min of, and I look for the y value, negative 0.3 at 1.5. And finally, I have a global min of, and once again, I look at the y value, negative 3.3 at negative 1.2. Didn't need the parentheses, just put it there. So, given the graph, it's very easy to identify where these guys are. But let's say you've just got some function, and you have to find the max and the minimum values. Well, we don't know how to graph this yet, so we're going to let our calculator do some of the work. So let's get that out. So once you've got your calculator on, you're going to go to hit y equals, and you're going to type in the function over here to the left. So I take 4x, and when I want to raise something, I use this caret button right here. It's right under clear to the fifth, minus 3x to the fourth, plus 4x squared minus 10, and pop that into the y1 line. Now if I want to graph this, all of us may have a different graph that we're looking at, even though we look at this same function, depending on the window we look at. And the window is basically our home screen. So let's just, so we're all looking at the same thing, hit this zoom button, followed by standard. And what the standard does is it puts my window in a 10 by 10 for both the x and y axis window, or negative 10 to positive 10 if you will. And then I go ahead and graph this. So this is what we should all have pictured. And I can see that this is some function that goes up forever, but I look down here and it looks like some of this maximum and minimum value kind of stuff is happening. Well, I want to see this a lot closer. So what I'm going to do is I'm going to change my window so I can see lower. So let's do this. Let's take and hit the window button, move down, and let's make our y go to negative 20. And once our y is negative 20, we're going to take and graph it again. And we should all be looking at the same thing now. So you can see that this graph moves up, goes back down, and then comes back up again. And it appears to do that forever, and it actually does. But I want to look at this area a little bit more. So we're going to zoom again, but this time we're going to do something called a box zoom. So I hit zoom, and I hit box right here, number 1. And what that's going to do is it's going to put this little blinky guy up on the screen. And what I want to do is I want to use my arrows to move this blinky guy just to the upper left of what I want to look at in the function. Once I have it right around here, doesn't need to be the same for everybody, but once I have it right around here, I hit enter, and then I move that blink to the right, and you'll notice I'm creating a horizontal line, and I want to drag it over just about to here, and then I drag it down, and notice what it creates. It creates a rectangle or a box around the area I'm mostly concerned with. Once I've done that, I hit enter, and now my window will blow up to the box's size. And we can now see the fluctuations of this graph much better. So once again, we've been asked to find the maximum and minimum values, as well as where the function increases or decreases. So what we have to do is find this high point and this low point. And our calculator will do that too. There's a couple of ways that we can go about doing it. The way that I'd like you to do is use something called calculate, and that's this button right above trace right here. Notice it's in blue, so I go second, and then I hit the trace button, which makes me go to the calculate screen. And what I want to do is calculate a maximum, and you'll see that it says left bound, and there's this blinky guy. I want to take that blinker and move it to the left of the high point. So I'm going to drag it over using my arrow key. Once it's to the left of the high point, it can be anywhere left. I hit enter. Then it says right bound, and I'm going to drag it again to the right of that high point. And anywhere to the right's fine. Once it's there, I hit enter again. And every time it's going to hit guess, I still can't figure out why the calculator does this. But it gives us this guess, which means nothing, and we hit enter a third time, and the calculator goes right ahead and calculates a maximum value, and we're going to round that to the, let's say, 10. All right. So what I have is I have a max. Well, let's just sketch this graph out while we're here. It does something like this. And given that, go back to our calculator and find those numbers again. This is the point negative 0.58 and negative 9.2. So we'll write this in here. You have negative 0.58 and negative 9.2. Then we'll go back to our calculator, and we're going to find out what this low point is. So let's go ahead and do that. We're going to hit calculate once again, second calculate, and we're going to go a minimum value now. So that's the number 3. And it's going to say left bound again, so I want to go to the left of that minimum, hit enter, and then to the right of that minimum, hit enter. Once again, we'll get that guess. We hit enter a third time, and it's going to calculate the minimum value, which is 3.0, and then it says e to the negative 6. That's scientific notation, so that's basically 0 and then negative 10. So this point down here is the point 0 and negative 10. So given that, we can now state where our maximum and minimum values are, as well as where this function increases and decreases. Let's go increasing first. So you'll notice we increase as we come from here up and then from here up. So in terms of interval notation, I go from negative infinity to negative 0.58. And then once again, I go from 0 to infinity. As far as decreasing, that's going to go from negative 0.58 to 0. When we talk our maximum and minimum values, we have a max that's a relative, and that's a relative max at negative 9.2 at a value of negative 0.58. We have a relative min of negative 10 at 0. So these are just some of the descriptions we can use for functions in terms of maximum, minimum values and increasing and decreasing. Some of the other things we also do is we'll state where, in fact, that functions are positive and negative. In this case, we're going to find out where a function is positive. So again, we'll have to go to our calculator to graph this because we're not equipped to do that yet. So once again, we go back to the calculator, hit y equals. To get your old function out, just hit clear. And then we're going to plug our new function in. Once you've plugged that new function into the calculator, we take and again, so we can all see the same thing, we're going to go back to our zoom button. And in this case, we're going to hit standard again. So that's 6. And we get a graph that looks like this. Now, if we want to talk, is this positive or negative in our graph? We want to know whether it's above the axis or below the axis. So we're going to have to find out these intercept points. And I think the easiest way to do it is by graphing a horizontal line at y equals 0 and then find the intersection points, because then I'll know those intercepts. So what we're going to do is we're going to hit y equals again, and as a second function, we're going to graph y equals 0. So now if I graph that, here's that first curved function, and then you can't really see it because the line already there, but it's also graphed y equals 0. And now we're going to find these intersection points. So to do that, I go second, calculate, and here's this button number 5 that says intersect, and it will ask me to identify one of the curves. So I'm on the curved function now, not the straight line, and what I want to do is I want to take that blinker towards the first intersection point, which is close enough here. So I hit enter the first time, it picks the second curve, which is on my horizontal line, then once again uses this guess feature, which means nothing. Hit enter the third time, and here's my intersection point at negative 1, 0. So again, let's go ahead and graph a sketch of this. It's something like this, and we have a line cutting across, and this is the line, or the point, sorry, negative 1, 0, right here. Now I need to find that next point, so I'm going to hit second calculate again, find the intersection, and now my first curve, I want to move that over to my second intersection, and it just has to be relatively close, and hit enter 3 times, 1, 2, and 3, and it will find this second intersection point, which happens to be at 1, 0. And then I have to find my third intersection point. So again, back to the calculator, second calculate, intersect, move it to my third intersection point or right around that point, hit enter 3 times, and our final intersection point of 2, 0. So in this case, if we want to know where this is positive, it's where is the graph above the x-axis? Well, that's in this area here and this area here. So we say that by, again, using x intervals. And that happens when x is between negative 1 and 1. Again, that's not a point, it's an x interval. And then from 2 to infinity. So that's how we'd state when it's positive in terms of intervals for the graph. Next, we're going to talk about something called the average rate of change, which sounds very difficult, but it's actually just the slope. And we know slope as y2 minus y1 over x2 minus x1. Putting that in function notation, given 2 points, f of b minus f of a over b minus a. So here's an example question. We want to find the average rate of change of the function over the interval -1 to 3. And again, there's this word interval. Interval means x values. So this is like x1 and this is like x2. Which means if we're going to find the average rate of change or a slope, we need y values. So in order to find the y values for these given x's, we're going to have to plug these in. So I take f of -1 and find f of positive 3, sorry. F of -1 is going to get me a -1 here, followed by a -2, which is -3, and add that, I get a -2. F of 3 gets me a 27, and a 6, which is 33, and a 1, which is 34. So if I want the average rate of change, I take f of b, which in this case is 34, minus f of a, which is -2, over b, which is 3, minus a, which is -1, giving me 36 over 4, which ends up being 9, and that's my average rate of change. Finally, we talk about functions that are even and odd, and we've actually done this already, except using other terminology. Even functions are functions that are symmetric over the y-axis, so they have y-axis symmetry. Odd functions are symmetric over the origin, and those have origin symmetry. And we've already tested for these earlier this year. So we know that if we have y-axis symmetry, then we have the opposite of x and y, and if we have origin symmetry, we have the opposite of x and the opposite of y. So in order to test these, we just plug these points into our function and see if we get back our original. Right? And in each of these, we want to test if it's even, odd, or neither. So we plug in, and let's just go for even first. For those even functions, we want to plug in a -x. So I get 6 and -x to the 5th, minus 4 and -x to the 7th is equal to y. See if that's going to be true. We get -6x to the 5th here, and that's going to end up being a positive 4x to the 7th here is going to equal y. There's no way I get that back to my original, so that's not even. Check for odd. Once again, we're going to take and plug -x, -y in. Well, if -x got me this, then -y will get me -6x to the 5th plus 4x to the 7th equals -y. Notice I want to get y to a positive, so this goes to 6x to the 5th minus 4x to the 7th, and that's the original, so this is an odd function. Let's move to the next one, check even. So I plug in a -x and a y, so that's y equals 3 -x quantity squared over 5 minus 9 -x to the 4th, which gives me 3x squared minus 5 minus 9x to the 4th. And what do you know? Same guy, so this is an even function. Could they be both? Yes. Is this one? No. So I'm not even going to test it. And we take a look at this guy. So we look at even again, and we say y is equal to 2 minus opposite of x to the third plus negative x. This gives me y equals 2 plus y, x cubed minus x. No way does that look like the original, or will it ever? So that's not even. And let's go with odd. I have negative y equals 2 plus x cubed minus x. I've already made that substitution for negative x because I get the same as I had when I was even. Make y positive. That gives me negative 2 minus x cubed plus x. The negative x cubed and the x are the same, but this 2 has gone negative, so this doesn't work either. So this is neither. So today we've talked about some properties of functions, used our calculator to find some maximum and minimums. If you need to watch this again, the link's on the homework part of the site, so you can go ahead and watch this at your convenience at your own home. Or if you've got the notes down today, you'll be ready to go on the homework tonight. And I'll see you tomorrow.